Welcome back to the GCSE Maths Pro YouTube channel. Today's video is the second part of compound interest where we're going to be looking at harder questions. Most of these questions are just for higher tier only. If you're foundation tier, make sure to go back and check out the first compound interest video. So just a recap of the compound interest formula, if you haven't already noted it down, basically going to be using our calculators to put the initial amount, multiply it by 1 plus the percentage as a decimal, and to the power of how many years. So as you can see, I'll have the formula on every page anyway, but it is a good idea to get used to this formula and try and memorize it if you can. So let's look at some of the harder questions. First of all, we have Santiago invested £1,500 into an account paying compound interest at a rate of 2.5% for the first year, then 0.9% each year after. Work out the value of his account after 4 years. So this is quite a common question where you've got two different interest rates for two different periods of time. So we're going to have to use the formula twice. I'm first going to start obviously with the first year, right, which is 2.5%. So my initial amount is 1,500. So I've got 1,500 times by 1 plus my interest rate over 100 to make it a decimal. And then technically to the power of the time or the years, it says for the first year. So obviously that's technically to the power of 1. Doesn't really make much difference though. So then I'm going to put that into my calculator. Okay, and that gives me 1,537.50. So that's the value of my account after 1 year. I still have the 1,500 plus any interest for the first year. Now we've done that, we then want to look at the different interest rate, which will be 0.9% for all of the other years. Because here we've done 1 year and we know the total is 4 years, we now need 3 more years at 0.9%. So I'm going to use the same formula, however my initial amount is now going to be the 1,537.50 because if you think about it in terms of timeline, at the start the initial amount was 1,500, then after 1 year, this is what I got. So now we're kind of stood at the start of year 2, aren't we? So the initial amount for year 2 is going to be this. Okay, so you have to take that as your new initial amount, so just make sure you do that. And then times it by 1 plus the interest rate, which is now 0.9, over 100 to make it decimal, and then to the power of the years. Now, because we already said we've used 1 year out of 4, so the other remaining 3 years is what we need. Then we put equals, obviously put that in your calculator. Okay, I'm going to round it to 2 decimal places just because it's money. So we've got £1,579.39. And that was for the other 3 years. So obviously in total, we have the 4 years accounted for. So I've just had to kind of split it into 2 parts basically, use the formula twice. The key thing is to remember that your initial amount will change once you've already worked it out once. You have to use your answer as the new initial amount for the second calculation. Otherwise, it is pretty much the same thing. So that's all we have to do for that question. Your answer is £1,579.39 because they've asked for the value of his account, not just the interest. Okay, so let's look at a different one. Sasha invests £4,000 into an account paying compound interest at a rate of R% per annum. The value of his account after 3 years is £4,060.30. Work out the value of R to 1 decimal place. Okay, so basically work out the interest rate. We're going to have to go backwards now. So you can see, of our formula, we've been given the initial amount, we've been given the time, and this is effectively the answer, isn't it? So I'm going to set up my equation with all of these pieces. So my initial amount is 4,000 times by 1 plus, now I don't know what the percentage is, so I'm going to use the letter R again, over 100, to the power of 3 years, and then I can put that as equal to £4,060.30. So you can see I've created an equation, and the only letter that I don't have is R. So all I now need to do, I can almost forget about compound interest at this point. I've used compound interest to know how to set up an equation, but now it's just basically algebra in terms of I need to solve this equation. I need to rearrange it to get R as the subject, and then obviously that would have solved it. So the first thing I'm going to do to rearrange it is I'm going to divide by this initial amount, okay? Obviously all of these are likely to be calculator questions. So divide £4,060.30 divided by 4,000. So we get all of this. I would just copy it all down to be honest, but in your calculator we can use the answer button so that we don't have to keep copying it out. So I'm obviously left on my left hand side with just this bracket with the power of 3. So I get 1 plus r over 100 cubed still, because I've cancelled out this 4,000, equals all of this decimal. Okay, the next thing I need to do is cube root. The opposite of cubing is cube rooting. So I need to cube root both sides of my equation. so that I can open up those brackets. Obviously, again, I'm going to do it on my calculator. What I'm going to do is use the answer button. You see this one down here. It's just going to copy all of these decimals. So to get the cube root, you might have to press the shift. You can see here I've got square root. Just above it is the cube root symbol. So I put shift and then the square root gives me a cube root. You can see there's a 3 there. Put the answer button and then this is what I get. So on the left hand side, obviously it opens up this brackets here. Basically, I still have 1 plus r over 100. And then on the right hand side, I'm going to write this down. As you can see though, it is basically 0.004999999 and so on. So I'm probably just going to round that at this point, okay? So I'm going to write it as 1.005, okay? Because that's effectively what it is, isn't it? Okay, now it's pretty straightforward. I'm obviously just going to subtract 1 and then times by 100. I get r over 100 is equal to 0.005, and then I will obviously have to times by 100. I'm just going to put it over here, so that gives me r is equal to, and if we times this by 100, we get 0.5, and that's now in percentage format. So it says leave it to 1 decimal place. I already rounded it over here, but effectively that's what you would get. 0.5% was the rate of interest. So that is your answer. So again, this is quite a common question. You might have to work backwards to find out the original interest rate, for example. Just set up the equation and then solve it as if it were a normal rearranging question. Okay, this one's kind of similar, but there's just a little bit more to it, so it's a little bit harder. Camille invests $2,500 into an account paying compound interest at a rate of R% per annum. After 5 years, she had to pay 20% income tax on the interest she earned. Camille paid £41.30 tax. Work out the interest rate. So it's kind of the same question in terms of the fact that we need to work backwards to find R. But we've not been given the end value of the account, we've been given the tax that was paid, so it's kind of a few steps in front of what we just did in the previous one. A lot of students struggle with this question because they don't really understand the concept of what's going on or the kind of the real life logic to it. And basically what it is obviously, let's say for example if you were to earn a lot of interest, the government can technically charge you tax on that because it's like an income. So what's happened here? Camille's invested her £2,500 for 5 years. She's left it alone. It's grown interest every single year. And then at the end of the 5 years, however much money she earned in interest, so whatever's additional to the £2,500, she then had to pay 20% of that, which was £41.30. So in this case, £41.30 is equal to 20% of her total interest. That's what we need to understand. So we're starting off actually with the topic of reverse percentages. Reversing because I want to know what is 100% of the interest. So I need to kind of go backwards and go, right, if this is 20%, what's 100%? Now, you've got two options. One, you could just times it by 5 because 20 times 5 gives you 100%. But that doesn't always work for every single percentage, right? It could be a really awkward percentage, so I wouldn't rely on that. Reverse percentages, what I do is I take the actual value, so £41.30. Reverse means we're going to divide, because normally you times, don't you? And then divide by the decimal version. So obviously 20% is 0.2, isn't it? If I put that in my calculator, it will give me automatically 100%, and that will work for any percentage that you need to reverse. So £41.30 divided by 0.2 gives me 206.50. Okay, so her actual interest that she earned over the 5 years was 206.50. All right, for our compound interest formula, this formula gives us the total value of the account at the end of the time, doesn't it? So that also includes interest and the initial amount. So we need to add that back onto the initial amount to get the total value. So the value of her account at the end of 5 years is going to be 2,500 plus 206.50. And that's what we'll use to put into our formula over here. So that gives me 2,706.50. That's the value that she had in her account after 5 years. So this is kind of the additional bit we need to do for this question. From here, it's now the same exact steps that we did with the previous question. I can set up my equation, I put it equal to £2,706.50, and I reverse it to find R. So my compound interest formula, we take the initial amount, which is 2,500, times it by 1 plus the percentage rate over 100, which in this case we don't have, so we'll leave it as R, and then to the power of the time, which is 5 years, and that equals the value of the account after 5 years, so that's £2,706.50. Okay, we needed to work out all of this so that we could put it into our formula for compound interest. Now I'm just going to reverse it. So we first of all divide by the initial amount, so 2,706.50 divided by 2,500, which as you can see gives us 1.0826. I'm going to write that down. Then in this case, we need to reverse the power of 5, which is using our root. Now, obviously they have square root and cube root, but if you want to do your own number root, there's probably another button over here. So this one is x to the power of something, but then you can see if I press shift, it gives me this root symbol where I can change the number. So I'm doing it to the 5, and then I'm just gonna use my answer button to copy the 1.0826 equals. Okay, and again, same as the last one, you can see it's got this 999, so I'm probably just going to round to 1.016, just so I don't have to write it all down. Now, sometimes you might even be able to get to this point and go, oh, I can see what the interest rate is from here, but obviously we would technically subtract 1 from both sides to get 0.016, and then times it by 100 to convert it back to a percentage, which would give us 1.6%. So R is 1.6%, the interest rate is 1.6%. Okay, so the second half is exactly the same as the previous question. We just had additional tax and reverse percentages to deal with at the start. Okay, this is our last question. It's similar to some of the ones you would have seen in the first video, where we have two options. We have to investigate both and then give our answer or conclusion. But this one is technically harder because, as you can see, Bank 2 has this split interest rate as we saw in the first question. So hopefully by now you might have an idea of how to work this one out. So pause the video if you feel comfortable doing so, and let's go through it. Okay, so I've just drawn a line down the middle so I can deal with both scenarios separately. So let's see, Amy wants to invest £4,000 for 6 years. Which account would offer her more interest? Okay, well, we're going to use our formula for both of them. The first version is easier, so we've got 2% compound interest each year. So our initial amount is obviously 4,000 times by 1 plus 2% over 100, and then all of that to the power of 6. Okay, so we just put that in the calculator, which, as you can see, gives us £4,504.65 if I round it to 2 decimal places. Okay, now it does say which bank gives her more interest, so you could subtract the 4,000 if you want to isolate purely the interest. But technically, because we're starting off with the same amount, the initial amount is the same for both banks, 4,000 or 4,000, the bank that gives more interest will be the bank that gives you a higher value anyway. So you don't really need to work out the interest if you don't want to, but I'll just do it for the sake of it. So therefore, the interest would be, as you can see, if I subtract it, you can see it's obviously just £504.65 for that one. Okay, the second one, we have to do our split workings again. So Bank 2 offers 3% compound interest for 2 years, and then 1.2% compound interest each year after. So it's for 6 years. So obviously we're going to get 2 years at 3%, and then the other 4 years will be at 1.2%. So I'm going to start off with the same formula, and I'm going to do 3% for 2 years. So my initial amount is obviously 4,000 times by 1 plus 3 over 100 to the power of 2. Put that in my calculator, which gives me 4,243.60. And then I need to work out the other 4 years. So my initial amount is now going to be that same value. The 4,243.60 is the new initial amount that I need to use. And obviously my interest rate has changed to 1.2%. And then for 4 years, which gives me £4,450.99 if I do it to 2 decimal places. So again, my interest, I just have to subtract the initial £4,000 to get just the interest, which would be £450.99. Okay, so that's the working, but it does say which account would offer her more interest, so you have to do a conclusion. So therefore, Bank 1 would be your answer. That would give her more interest. So that is it for looking at harder compound interest style questions. The final video on compound interest is on decreasing values, or you might have heard it as depreciation. It doesn't really seem like compound interest, but it's the exact same formula pretty much, so definitely check that one out. Otherwise, thanks for watching this video. Hopefully you found it helpful. Leave down below any questions or comments you might have, and make sure to like and subscribe.